Alright, so we're graphing solving quadratic inequalities. Really, this is going to look a lot like, it's just going to be a good review of everything we've done so far. It's just that now we're interested in less than. So the biggest thing to notice is that we are going to do y is less than, which is going to require graphing it, and just an equation with just x's in it. It's quadratic that will not require graphing it, but may require a number line. So, in order to graph this, the first thing we know in standard form is the y-intercept. Because if you let x equal 0, that 0, so 2 times 0 minus 8, so you get negative 8. So we know the y-intercept is negative 8, down here. The next thing we did was that you could find the vertex. To find the vertex, or the axis of symmetry, x, we first found the x, and that was negative b over 2a. So that's negative 2 over 2 times 1. So that's negative 1. That's the x of the vertex. So you know that it's balanced someplace around here on the negative 1. And so that's the axis of symmetry, x of the v, or axis of symmetry. So if you plug it back in, you find the y. So negative 1 squared plus 2 times negative 1 minus 8. So that's 1 minus 2 minus 8, or negative 9. So the vertex is negative 1, negative 9. And so we also found the axis of symmetry, so we can reflect this over. And then finally, we can find our x-intercepts. And one thing you could do, like we talked about before, the generic thing is 1 squared is 1, and if you go left and right 2 from your vertex, you should go up 1, 2, 3, 1, 2, 3, 4. And you could do that on either side. And you could go up left and right 3 and go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you can get your x-intercepts that way. Or you could say that's when the y value equals 0. So 0 equals x squared plus 2x minus 8. And how you solve this is either by factoring, completing the square, or the quadratic formula. Those are the three methods that we talked about. So x and x, what multiplies to negative 8? 4 and 2, and if the 4 is positive and the 2 is negative, you get a positive 2. You can multiply that back out, you get that. It's factoring. So x equals negative 4 and x equals 2 are the x-intercepts. So 2 and negative 4 are the x-intercepts. And just remember that this right here, this being less than, is telling us that this should be a dashed. Sometimes I try to make a note of that before I even start, because otherwise I forget. I get so excited about drawing this parabola and you just sort of forget. So what we want to do now is y is less than. Well, all the y's that are less than this, any y's that are less than are below this, because bigger y's are up top, lower y's are in the bottom, and so we shade this right here. So it's kind of like shading above and below the line, except it's shading above and below the parabola, which is just a curve. So our solution is any point in this shaded area is a solution. Alright, so let's do another one very similar to it. So let's deal with this negative x squared minus 4 first. So first off, we did the y-intercept. That's where x equals 0, and so the y-intercept is negative 0 squared minus 4 times 0 equals 0. So the y-intercept goes right through there. Axis of symmetry and the vertex. Well, the vertex is negative b over 2a, like we did before. Negative b is a positive 4. It's a negative negative 4, so positive 4, over 2 times negative 1. Positive 4 divided by negative 2 is a negative 2. And so we're at negative 2 here. Again, that's x equals negative 2 is the axis of symmetry. And if you plug it back in, y equals negative 2 squared. Sorry, a negative of the negative 2 squared minus 4 times negative 2. So this is 4, but then when you make it negative again, these negatives don't cancel out. Keep that in mind. Order of operations says that these have to come together. So you get a negative 4 plus 8, so you get 4. So the vertex is negative 2, comma 4. 1, 2, 3, 4. Which makes sense, because if we now do our zeros, or left and right 2, down 4, we get this one. And so I'm going to make this one dashed just like we did before. And our x-intercepts are 0 equals negative x squared minus 4x. Or if you make it all positive, divide through by the negative, you get x squared plus 4x. So factor out the x and you get x plus 4. So x equals 0 and x equals negative 4 are x-intercepts, and that's what we got. So that's the one. And now we do y is greater than or equal to x squared. Sorry, when we graph this now, it's y is less than, and so we are going to shade below. Y is greater than or equal to x squared minus 2x minus 3. Okay. So this is the y-intercept. Always just the c value. 0, negative 3. 1, 2, 3. The vertex. Negative b over 2a. So that's positive 2, negative negative 2 over 2 times 1. And so that's 2 divided by 2, or 1. So we have our another axis of symmetry over here. And y equals 1 squared minus 2 times 1 minus 3. And so what we get here, 1 minus 2 minus 3 is a negative 4. Is that right? Yeah. So you get negative 4 is the vertex. 1, negative 4. And again, so you could do that there. You could do left and right 2 and up 1, 2, 3, 4. So that's the other x-intercepts. And so you can graph it. I'm going to confirm that those are algebraically x-intercepts. And what you get is that we shade greater than this one, and so the overlap is right here. And that is where the solution is. Because we're interested in what? Because it's a system of quadratic inequalities. Sorry, the x-intercepts, just for fun, are 0 equals x squared minus 2x minus 3. So what multiplies to negative 3 and adds to negative 2? So x minus 3, x plus 1. So 3 and negative 1. Alright. So this is where our overlap happens, and that is the solution to our system. Let's try another. We're going to solve this one. Notice that I don't have a coordinate grid over here. Notice that we don't have a y. So first thing I'm going to do is I'm wondering where x squared plus 3x is less than or equal to 10. And if we solve this by setting it equal to 0 in a sense, less than or equal to 0, pretend like you set it equal to 0. And I'm going to show you what I mean by a table. And so we use a table of values, make this x, make this y, or make this, in a sense, x squared plus 3x minus 10. Utilize the table in the graphing calculator. I'm going to make in y equals x squared plus 3x minus 10. Oops, and I didn't mean to graph it, but we're going to use that to our advantage here in a second. And here it is. So notice, if you scroll up, we have a bunch of negative values. That's where it's less than 0, so we want to take a note of that. But maybe we could start our table around negative 1. Goes 0, 1, 2, 5, and then it comes back down again. Hold on. What's going on here? X squared plus 3x minus 10. That's right. So if we start it, sorry, not thinking, because it opens up. Notice how it goes from 0, negative 6, down to negative 12, back up to negative 6, and back up to 0. That's what we want. So I'm going to say negative 6, negative 5, 3, 2, negative 1, 0, 1, 2, 3. So if you fill out your table, 3 is 8, 0, negative 6, negative 10, negative 12, negative 12, negative 10. Notice how it's symmetric too, as long as it's nice and pretty integer values. So, what I mean by using this table: negative 5, 0, and 2, 0. We want to answer the question, what x values give us a value less than or equal to 0? So, well, negative 5 gives us 0, and 2 gives us 0, and then all of these values in between are negative. And so when x is greater than or equal to negative 5, and when it's less than or equal to, what was that, 2? Or we typically write it, negative 5 is less than or equal to x is less than or equal to 2, because you can flip this inequality around. And it's everything in between negative 5 and 2. So, a couple different ways we can do this. I like it graphically just because I'm very visual like that. 3x squared plus 5x minus 3. And let's move the 1 over. So you would get minus, if you subtract 1 from both sides, you get minus 4. Sorry. And then you're wondering where this is less than or equal to 0. And so what we're looking for is visually, where is the parabola less than 0? Thinking the y values, or negative. And so what I'm going to do is I'm going to graph it. I'm going to use it graphically to my advantage. In y equals 3x squared plus 5x minus 4. And so one way of doing this is, so you have it graphically here. And so where is this happening? Well, you could trace, right? Or we calculated that value. So I'm going to, 1, it looks like it's crossing at 2.5 and about a half. So I'm going to just sketch it from what we have on there. I'm looking for where is it less than. And remember, I'm graphing it like this, but there's still no y, so I'm not going to shade it. I'm just interested in right here. From this x to this x, it is less than 0. And that is what I'm interested in. So, Notice that if you just moved everything to the other side, you'd be wondering where it was greater than 0, but then you'd have a parabola that was opening upside down, and so it'd still be the same amount in there. So how do we calculate this? Well, you could use quadratic formula. I'm going to use the 0 feature. And so we've done this before. Go to the left of where it crosses, hit enter. Go to the right of where it crosses, hit enter, and then just hit enter again. This negative 1e, negative 12, is scientific notation for 0.00000. Negative 1 times 10 to the negative 12th. 11 zeros and then the negative 1. So x is approximately negative 2.257, and approximately, hit second and then calculate. And I'm scrolling over to the left of it and then to the right of it. Imagine that vertical line going left and right. 0.591. 0.591. So we want to know it's in between that amount. And so negative 2.257 is less than x, which is less than 0.591. Now realize this is an approximate value because we haven't actually solved it algebraically, meaning using quadratic formula, things like that. That's what we're going to do next. So if we do need to solve it algebraically, let's say we have x squared plus 10x minus 9 is less than 0. And I added 10x to the other side, that's got there, and so now it's less than 0. If you factor this, what multiplies to 9, and so minus 9, sorry, this was plus 9. So plus 9 plus 1. So if this was equal to 0, x would be equal to 0 at negative 9 and at negative 1. So even though I'm using an algebraic approach, I still want to think about, okay, at negative 1 and negative 9 it's crossing. This is a parabola opening up. So where is it? I'm sorry. You know what? Let's change this sign so that it's greater than, just so we can see what else happens. I'm changing the sign, let it be known. So greater than 0. So I want to know, okay, it's greater than 0 here and here. And other people would do a sign test where you plug in, say, negative 10, you plug in negative 5, and you plug in 0. Something in all of these parts. But I know graphically what it looks like, so I don't really need to do a sign test. So when it's less than 9, when x is less than negative 9, or when x is greater than negative 1. Notice that I can't do a compound inequality, meaning this, because this is always meaning an and it's always in between. And then let's do it with this one, negative 3x squared plus 10x. Add the two. When is it greater than 0? This one does not factor. And so we're going to have to use, say, quadratic formula because it works. And so we're going to find the exact values for this one. So x equals negative b plus or minus the square root of b squared, 10 squared minus 4, times a, which is negative 3, times c, which is 2, all over 2 times negative 3. Now 100 minus a negative, so this is going to be really adding 12, 24, so 124 over negative 6. And so what we get is negative 10 plus or minus. There's a 4 in here. This is 4 times 31. And so 2 root 31 over negative 6. And I'm going to split this up. negative 10 over negative 6 plus or minus 2 over negative 6 root 31. And so what we can do is reduce this to 5 over 3. And the 2 over 6 reduces to 1/3. Now, there was a negative 6 in the bottom. And so I could write negative 3. But if I add a negative 3, it's really just like subtracting. And if I subtract a negative, it's really just like adding. So this is what I'm going to keep, except for the fact that I want it to be, think of it graphically. This is an upside down parabola. I want to know when it's positive. So it's going to be in between those two zeros. So which one's the smaller one? Well, if I subtract 5/3 minus root 31 over 3, that's the smaller one. And so that has to be less than x, which is less than when I add the two. Alright. So let's plant a garden. A little story problem. See how this is acting as a nice review for everything that we've done. So, Kina wants to plant a garden and surround it with decorative stones. She has enough stones to enclose a rectangular garden with a perimeter of 68. But she wants the garden to cover no more than 200 square feet. So we want the area to be less than or equal to 240 square feet. Doesn't want it taking up too much of the yard. So, what could the width of our garden be? So remember we have, say, some width and some length, x and y. So based on the perimeter, we have 2 x's and 2 y's equaling 68. Or in other words, if you divide by 2, x plus y equal to 34. That's how x and y are related. But x and y are also related by the area. And the area is what we want to minimize. And so, or what we want to find what it could be. So this is going to be x times y has to be less than or equal to 240, because if we multiply them together. So if I solve this, say we solve it for y and we say y is 34 minus x, I can do a little substitution. Less than or equal to 240. And after we substitute in for the y, we can multiply this back out. 34x minus x squared less than or equal to 240. And we could move the 240 over. We get negative x squared plus 34x minus 240. And, or if you preferred, we could have moved it to the other side. I'm kind of partial. You know what? Positive x squared's all the way. Because if we can factor, which in this case we can, it's really nice. What multiplies to 240 and adds to 34? And so we can come up with 12 and 20. 20 times 12, you know what? Work. Okay, so what else could we use if it's not 12 and 20? What about 10 and 24? 10 and 24 add to 34. So that means x has to be equal to 10 and x has to be equal to 24. Now that makes it equal exactly to 240. And so if we think, well, it's got to be less than 240. So in order, or we want to know when our parabola is greater than 0, the parabola is going to look like this. Here's 10, here's 24. We want it to either be over here or over here. So the width has to be less than 10 or greater than 24. And I'm going to say less than or equal to because it could be equal to that amount. And so x has to be less than 10 or x has to be greater than or equal to 24. And that would go either way with it. So that is how you solve inequalities. We used a table. Noticing where it was less than 0, we did it graphically with y's and we had to shade it when y's and x's were involved. We used a graph to sort of figure out, we could use it approximately, or we'd use factoring or quadratic formula still to figure out when it was greater than 0 or less than 0. And there you have it.